guys, what's the crack? So I got asked to do some more harder electricity questions. I think this one's quite a good one because it's seeing if you actually understand how to connect circuits. So one says that we want to look at the current voltage characteristic between 0 and 6 volts for a filament lamp. It says the battery has an EMF of 6 volts. So all these batteries have an EMF of 6 volts and it has negligible internal resistance. Okay, so what we're looking at is that we want the potential difference across the bulb to either be 0 or 6. Okay, so hopefully what we can see here, because of the way this circuit's connected and the electrons, conventional current flows in this direction, we're always going to lose some energy going across this variable resistor. Because we're going to always lose some energy across it, we're never going to get a maximum of 6 across this bulb. That's why it can't be this one. If we look at this one, option B, I can see that when my electrons leave my circuit, they're going through the ammeter. They can then go through my fixed resistor, or this can also be called a potential divider circuit or a rheostat. So what you can do is you can change the contact point. So what it's really saying here, if I draw B out differently, is that I can connect it in 2 different ways. So the arrow shows us we can adjust things. So I can either connect the bulb at the extreme end, so we can connect it up here with our voltmeter, measuring the potential difference across it. Or what we can do is we connect our bulb, we move the arrow to the other extreme end. So what I'm doing then is I put my bulb here and the voltmeter across it. Okay? So what we're looking at then is we can see when the bulb's connected like this, we can see that you've technically short-circuited the bulb. So it's called a short circuit. So what that means is if I'm an electron, none of the electrons are going to want to take this path through the bulb because they're going to take the path of the least resistance. We completely short-circuited it. So that means the current for that bulb there is going to be 0 amps. So the current for the bulb is 0 amps. That means there's going to be the potential difference across the bulb is also going to be 0 volts. Right? There's going to be no energy lost going across that bulb. And then what I can do when I connect the bulb here, when I connect completely across my fixed resistor, because then they're in parallel to each other, we know that the potential difference across the cell is going to be equal to the potential difference across each component in parallel. So that's where we're going to get a maximum of 6 volts. So B looks pretty good so far. Again, A is the exact same as B. The only thing is we've moved the ammeter from here in the circuit to here in the circuit. So again, A looks pretty good because I can get 0 amps or 0 volts and I can get 6 volts. If I look at C though, I can see that when my electrons leave the circuit, they have to go through this variable resistor. So they're always going to lose some energy in going through that variable resistor. So because they're going to lose some of that 6 volts, some of that energy per unit charge on going through that variable resistor, there's no way to get a maximum of 6 across that bulb. Okay? So it can't be option C. So now we're thinking, what's the difference between A and B? What is the best circuit to use if we're trying to find out the current voltage characteristics of our filament lamp? Okay, so I want to know the current for the filament lamp and the potential difference across the lamp. So here the voltmeters are both connected across the bulb. That looks pretty good, my filament lamp. But here my ammeter is connected, tell me the current that's going to be flowing through the whole circuit. It's not going to directly tell me the current for the bulb. Whereas here, because the way the ammeter is connected, it's always going to tell me the current for the bulb. So again, if we short circuit it and all the electrons take this path and they don't go through the bulb, that's why the ammeter will say 0. And the voltmeter then is going to be 0 because there's no energy lost across it. But again, if we connect it at the maximum, we then figure out what current is just going through the bulb. So option A is our best option in looking at the current and voltage characteristics of the filament bulb only.